I have 4:30, so got a lot of people here. So I'm going to get started. Hopefully we won't take the full 90 minutes unless there's a lot of questions because last session of the day. How's everybody holding up, by the way? Good. Yeah, and thanks for coming here because I know you had a lot of choice in airlines, and I'm glad you picked us today. My name is David Turanski. I'm currently working on the Spring XD team. And has anybody worked with XD yet or went to one of the sessions, the Mark sessions? Did you go to that today? Yeah, okay. Before that, I was the lead on Spring data-gem-fire. I'm kind of transitioning that to John Blum, who's sitting back here. And he'll be taking over Spring data-gem-fire so I can devote my time to XD. And done some work with Spring integration. This is Luke Taylor, a veteran Spring source guy. And he's come all the way from Glasgow to talk about real-time analytics. And he's was the lead on Spring security and done a bunch of other stuff. I mean, he's got a pretty fascinating history with Spring. But he's decided after doing this demo that he's going to just work with JavaScript from now on. He's done with Java. So we're going to talk about Spring XD. And I know if you saw the keynote, there was a lot of emphasis on Hadoop, big data. You think of Hadoop, you're ingesting big data streams, and you're going to do something with Hadoop, which is basically a batch process. But sometimes you want to know what's going on right now, what's happening with your business, what events, what transactions are occurring, and there's many applications, many use cases for doing real-time analytics, and of course, a really hot field right now. Any data scientists here? So we don't claim to know anything about data science. We at this point know a whole lot about Twitter, so we're going to show you some Twitter stuff. But characteristics of real-time analytics, these type of applications are event-driven, of course. You want to be very reactive. You want to be asynchronous and get events. And when we're talking about event notification, it could be to a human, stock trader, somebody wants to see stock prices or see trades that are happening. Or it could be to a system actor who is going to do something in response to that event. But important to be very timely in that response. A lot of event or real-time analytics will involve simple metrics like counting page hits, counting tweets that are coming, things like that. But you can get more elaborate. I know the keynote last night showed an aggregate counter where you can break things out by time buckets. We have gauges, moving averages, things like that are all essential. A lot of statistical analysis is involved in real-time analytics. And then you can go all the way to sort of complex event processing, which involves aggregating or correlating events. I know John Davies did a talk about rules and CEP and things like that, if anybody went to that. We're not going to talk a whole lot about that, but just to kind of mention that a lot of things are possible where you're saying, well, if A happens and B happens and C doesn't happen, then do this. So sort of really complex monitoring more than just counting things and looking at averages. So all of that are characteristics of real-time analytics applications. And since we're going to be demoing some things with Spring XD, just want to review some things. We consider it a sort of a one-time shop or one-stop shop, basically a integrated platform that is geared towards big data ingestion. It can support real-time analytics, and we'll look at what you get out of the box today, as well as ways that it can be extended by exporting data to other systems. We talk about workflow orchestration and data export. And it's all built on Spring, and primarily Spring integration, Spring batch, and Spring data are the key components. Anybody develop with Spring integration here? Good, okay, good. And of course, XD, in case you were wondering what that stands for, it's extreme data. This picture, I don't know if it's easy to see. It's basically this version of what the Marks showed last night. But we're ingesting data, and you can think of a work stream that's feeding HDFS. And we want to basically create a tap on that data to do real-time analytics. We want to get a copy of those messages that are coming through to Hadoop, so we want to look at them right now. Or, you know, that could be a filtered event stream, or we could look at all of them, whatever the application requires. And we can do analytics, and with tools like Redis, which Mark showed last night, where we have some metrics repositories that we use Redis to back. Or you can push stuff out to GemFire. We have first-class support for GemFire in XD, or something else. And on the export side, you could push data into a relational database. You can push into an OLAP tool, Greenplum, something like that, or Splunk. You know, all of these things are possible. It's open source, of course, and what we're building is a platform with executable services. It's not a bunch of jars. It's not, you know, an application framework. You saw the programming model is high-level DSL that we're using, which configures streams for ingest or taps for real-time analytics. And we provide some REST services to interact with the runtime environment. It's also, we'll talk about modules, and mention here that modules are pluggable, meaning you can provide your own modules. We provide some out of the box. And we look at the DSL. It's based on the familiar Unix pipes and filters syntax. In this case, the filters, HTTP and file, are modules. So HTTP is a source module, and file is a sync module, and the pipe is actually, in general, represents some kind of distributed transport between those two things. So, you know, we're talking about, you know, a very simple kind of intuitive way of creating mostly linear types of streams or linear types of pipes and filters composition. But you see that pipe, that there's a whole lot going on in the background there. And the DSL supports the composition of source to sync kind of things. It also, you can use command line parameters to configure things. So you want to set the port for the HTTP source, or, you know, where you want to post data to, and the file sync, where do you want to save that data, that kind of thing. So just a very high level overview here. So we talk about it, a stream. It's a composition of modules, and a module is basically a Spring Bean definition file, and primarily we're looking at a Spring integration flow that's got channels to attach to the other components. So we have module types are source, processor, sync, job, and trigger. We're going to talk just about source, processors, and syncs. And so in general, the definition of a stream is it always starts with a source and it always ends with a sync. And in between, you have processors, and you can chain them together as many as you need to do sort of a transformation of data. A source has one channel called output. And so it's getting data, it's feeding data from an external source like Twitter or HTTP. It's waiting for something to happen that will trigger the stream. And a processor or a sync has an input, and it's going to dump that data to some external resource. So we're done with it when it hits the sync. In between, processors have input and output. So that's the real basic distinction here, the concept. Take a look at the technical documentation here for a second to kind of look at what this looks like. So this is on our GitHub page, and you can see the sources that we provide out of the box today. There's a growing list. So HTTP, tail file, mail message, all these kinds of things. Twitter, most important one, obviously. Syncs. We can dump data to a log, a file, Hadoop, of course, JDBC, sort of data source, some TCP socket, Splunk, GemFire, those kind of things. And we look at processors. We have a few, but they're mostly some things we're doing with JSON. But the ones that are kind of important are transform and filter, and we'll see some examples of those. So going back, how do I get back? Ah, good. So just to drop down another level, so we have a simple stream definition. Say we have a source and a pipe and a sink. And so what's happening in XD there is we will deploy that stream through the XD admin. So we have an HTTP REST API that will the admin will take that command and say, okay, I need to deploy some streams. And in general, you can deploy to a cluster of nodes. So we have, in this case, showing 2 nodes. And the admin talks to those nodes, which are really the XD runtime containers, through what we're calling a control bus. So if you're using Redis transport, it would be a Redis queue, something like that. If you're using Rabbit, it would be a Rabbit queue. And the transports are pluggable. So Redis and Rabbit are ones we support today, but we expect there to be others, TCP or what is Stomp, whatever we want to do. So the module itself is a Spring application context. It lives in its own context, and we see there's a module, source module here. This source module, it's got an output stream, and generally it's going to be linked to some kind of adapter, depending on the transport. So that's what gets it on the remote data transport, or we're calling the data bus here, and it's going to attach to the sink through an inbound adapter. So Spring integration technology is under the cover, and that's basically it. So the idea is that the transport is pluggable. We have the idea of modules living in their own independent application context, which is kind of innovative at this point. I don't know many people who have thought about creating application context on steroids in the same JVM, but we have, we can potentially have a lot of them, and they're all kind of isolated, which is really nice or convenient in this case. And the single node version is kind of slimmed down. We're going to look at that today. We have an embedded Tomcat server in the same JVM as the runtime container. And in this case, we're connecting things through the data bus using bridges. So a Spring integration bridge would take the output channel and bridge it to a global channel that's going to be able to talk to that sink. So a little bit simpler model there, but the same kind of, shares a lot of the core architecture even in single node. So at this point, we're going to talk about taps. It's important to real-time analytics. So I'm going to turn it over to Luke.
Thanks, David. So we've already heard about streams there from David. Taps, a special kind of stream whose source is actually part of a stream that you've already created. And they're pretty important for what we're going to show you here, because it's usually the way we actually feed data into one of our metric modules. So, for example, if you had a Twitter search here, as we tend to do, you might want to then tap that data using the syntax in this second bullet point there to feed the data from your Twitter search into a field value counter to build up a set of counts of the hashtags in the tweets. More generally about Spring XD metrics and what we provide out of the box. All the metrics we have are implemented as modules. So almost always they're syncs. They're almost always attached to the end of taps because usually you're sending your data somewhere else. You want to tap the same data, put it into a module which is your metric. It's still early days in the project, so we don't have a massive amount of stuff there. It's all quite simple. We have simple counters, field value counters, which is what Mark was using in the keynote for his hashtag counter, and which we'll also use today. Aggregate counters, which Mark also showed you, and gauges. Two types of gauges. We may just change that eventually to be one. A gauge is essentially just a single value that you can read at any point. A typical example would be your CPU temperature or memory or some value that you have coming in from some remote server. Rich gauges provides a bit more data than a plain gauge, so it's a numeric value, but it also carries an average, which can be either a simple mean or it can be exponentially weighted average, so it takes more account of the later data. It also provides the minimum and maximum values that it's seen over the course of its lifetime. And we did actually have some extra slides here, which I was going to do, but we've taken them out, so I'm actually going to hand you right back to David to talk about GemFire.
Yeah. So I'm going to talk about GemFire a little bit. Being the outgoing project lead for Spring Data GemFire, I need to do product placement for GemFire. How many of you are familiar with GemFire? Okay, so I'll go through this pretty quickly, but if you don't know, it's a memory-oriented data grid for highly distributed systems. It's basically a big distributed cache, but it's more than that. It has some advanced features like continuous query and ability to execute remote functions, and I'll talk about some of that on the next slides. It's also got language interoperability, so it's got a kind of a proprietary advanced serialization mechanism. So the core server stuff is written in Java, but if you use Java I/O serialization, then you wouldn't be able to ingest this data into .NET, a C# or C++ client. So they've got GemFire's got something that's way more efficient than Java serialization, but also language portable. So it's very interoperable. And it supports various distributed system topologies. It's got, through Spring Data GemFire, full Spring support. It's very easy to configure and program with GemFire using Spring. And we'll look at some of that. And I think the bottom line is it's really well positioned for real-time analytics. It's very strategic for Pivotal at this point as sort of a major tool in the suite for real-time analytics, and we'll see kind of give you an example of what it kind of think it can do. GemFire is a commercial product; it's not open source. So function execution, and we're going to show this in the demo, but just to kind of look at some of the concepts. It's basically, let's bring the code to the data. We got a lot of data that's living out in the, in the cloud, and we don't want to pull everything down and do some processing on it when we can say, let's call this function that lives in that process, and GemFire knows how to find exactly which node which data is on, and run the code there. So if you're doing something that's like a complex aggregation function, something that's a little more data intensive, where you're looking at a lot of data, that's extremely efficient and saves you a lot of network traffic and so forth. It also can execute on multiple server nodes in parallel. So you basically have what is a MapReduce model, and in GemFire with function execution. You know, so the function is running on all the nodes where there's that data and doing this thing in parallel on that local data, pulling it all back together, and then you what's something called a result collector, which does the reduce part. So we'll look at some of that, but it kind of works a little bit like a remote procedure call. And we talk about continuous query. Well, that's a key component of complex event processing, the ability to, instead of executing a query and polling, let's just write the query and against the cache, and you know, these queries can be, you know, somewhat complex, and we want to know when something in that result set changes. And you know, so you get back the initial results, and then you're going to get the deltas back every time, or if something is deleted or something is created in that set that matches the criteria, you get notified through a callback mechanism. So GemFire is pretty rich in advanced features like that, and those things are, these things are very important for doing real-time analytics, or it can be very convenient, let's say. And with that, we're ready for the demo. There's a lot of moving parts, but Luke is going to describe what we're going to do.
Hello again. So again, we're going to be using Twitter. I'm going to talk you through some of the basic metric stuff that we have in Spring XD. We're going to have a look at that with a little dashboard that we've put together, which we may also start putting into XD so that you can build similar functionality yourselves. And then David's going to do some more advanced stuff with GemFire, which he can talk to you about in more detail afterwards. And with that, I'll probably just jump straight in here. So these are the different parts we have. We have the XD single node server, which is, what's the pointer of this one? Yeah, that's the main admin server, and also the containers, which you saw in one of the initial diagrams that David was showing there. Also what Mark was running. But we're not going to run here with Redis, we're just going to run with everything in memory. I think Mark's demo, he actually used Redis for the analytic storage. With the metrics, you can actually, you can either choose to have them just in memory storage, or you can have them persisted for where they outlive the lifetime of the single node. We're going to start the shell, which was the thing we issued commands with, and we're going to start this little dashboard app, which is just pure JavaScript. It's not actually using Spring or anything. It's actually just being served by Nginx, and it's making cross-domain requests to the admin server. So it's just making REST requests from the JavaScript to the standard REST API, which the XD admin server exposes. So we don't want GemFire. So we'll start the XD single node. So that's top left one. The shell. Nginx is already running for the web stuff. And then I'll try and create some streams and stuff. Hopefully Twitter's running. So stream, create, and tweets. Did everyone see, has everyone been to an XD presentation so far? Or seen the keynote? Yeah? So we don't have to go over this in too much detail. And we're going to just go for a plain Twitter stream source here, which just gives us a percentage of Twitter's overall output. And we're going to pipe that into a file or the log. We'll go for a file here, so it's just pushing that straight into a file. I've missed the definition parameter again, which I tend to do. Definition. Does that look right? Yeah, okay, good. And I'm going to undeploy it just now. So that stops it running and asking for data. Just check it looks okay. Doesn't look like anything went wrong. Okay.
Stream list.
Right, have we got the network on here?
Supposed to.
We are plugged in, yeah, okay. So tap, no, stream. Now we're going to create a couple of those taps with and pipe the data from the Twitter stream into particular metrics. So we're going to create one to look at the lang element. If you've seen a Twitter JSON message before, it has a lang element in it for the different languages that the tweets come in. So we're going to call that lang tap definition and tap tweets. Oops, tweets. And we're going to put that into field value counter. Field name. So field name is the parameter that the application context file, one of the parameters that the application context file exposes. So when that field value counter module file is loaded up, those properties are injected into the application context. And that's lang we want there.
Equals.
We need
Field name
equals sign. Equals, yeah, there's a slight syntax difference there. Right. So we'll try another one as well with the hashtags. We'll get 2 field value counters. Field value counter minus field name. And this is a nested property, so we need to use entities hashtags dot hashtags dot text. Looks good. Oh, we need the name for this one, don't we? Minus counter. No, that's okay. Yeah. Counter name equals hashtags. So that just gives it a name for in the registry. It makes it easier in the UI for us to actually pull it out. Okay, and let's try deploying. Stream deploy tweets. Okay. Let's see if it worked. And tweet view.
Tweet view 2.
Preview 2, we had to change the sizes for the thing here. Oops. Oh, wrong. That was you messing around.
Certainly right.
Okay. Oh, okay, cool. Right, so on the left we've got a pie chart showing the language field value counter. Whoops. And then we have on the right we've got a bubble chart, which is probably a better representation here. It's not quite fitting on the screen. And you can see as the language changes, the little bubbles are moving up and down the. And we can also have a look at the other one here, so we could look at the hashtags one instead, which is a lot more bubbles. And changing all the time again as well. And for some reason, there are always these really boring ones at the top. There's Game Insight, iPhone games, Android games, but there's lots of other stuff going on as well. So that's field value counters. Actually, nothing too complicated there. So we're going to create another one. And let's try, what are we doing? Stream create. Tweet count. So it's always the same thing. The tap's tapping into the same publish subscribe channel to pull the same data out from the Twitter stream source. Tweets to aggregate counter. Looks good. And that should, if I reload this now, we should get an aggregate counter down the bottom. Unfortunately, that's not fitting either too well, but that. Okay. That gauge was, are we looking at the right one here? Is this tweet view 2? The screen has again compressed my Twitter bootstrap columns, and they're starting to get pushed together. That gauge shouldn't be sitting on top of them. So basically we have, at the bottom there, we have the number of tweets per minute. That's the aggregate counter. You saw they were just switched over into the second bucket. You can also, we're only showing minutes here, but you can actually query by hour, by day, by week. And again, this is all just using the REST API underneath, so the REST API does, these are all just simple GET requests to Spring XD admin. And the gauge is showing the tweets per second there, which has just been calculated from that. It's not an actual gauge. And I should probably put that back to the hashtags because it looks better. Oops. Oh. Yeah, whoa, there they come. This is all done with D3. Has anyone used D3 before? It's cool, very cool thing. That's per minute, so those are the minute buckets for the aggregate counter. So it's actually getting more data back and saying, oh right, there's another minute. So it's actually showing the last, well, it's actually pulling back the last hour currently, I think. Because we're not putting any parameters in there. There's actually, if we look at the source, how do you look at the source in Chrome? What's the, is it Control U, like
Control O.
Firefox?
Control O.
Control L.
Oh, the screen source?
Yeah.
Yeah, I'm not sure.
I can show it from the, ooh. I'll show you in the command line what we have basically. Dashboard. HTML. So, yeah, if I tweet view. Tweet watch, tweet view. HTML. HTML, tweet view. God, so much tweet stuff. Oh, we're already in there, sorry. Right, so field value counters. So this is one for the aggregate counter here. So we're just calling to the base URL is the metrics URL, which is exposed by Spring XD. This one up the top here, localhost 8080/metrics. And for the aggregate counter, we're just calling, saying, give me JSON back from /metrics/aggregate counters, plus the name of the counter, and then there's a parameter here, which is the resolution we want, and it's minutes, it could be hours, it could be months, whatever. Okay, anything else there? No, I think I hand back to you at this point, don't I?
Sounds good.
Okay, cool.
All right, thanks. So Luke basically just showed what you can do out of the box with XD. Didn't really have to write any code except, you know, the eye candy. And everything, like he said, was just, let me go back to the picture here for a second. I mean, everything is just calling REST services from the XD, you know, to get those metric values, and then you can display it. So, but actually, the way he wrote the display is pretty generic, so it actually could work for any metrics. It doesn't depend on these particular metrics. So I'm going to show the other part here where we have GemFire. We're going to start a GemFire cache server and also a REST service. So it was just convenient to have another REST service endpoint that would basically pull the data out of GemFire so that we could show it with the JavaScript client here, the dashboard. And so I built a REST service with boot. You know, why else? I mean, I didn't want to spend a lot of time on it, so you know, I'll show you that. So anybody looked at boot yet? It's pretty cool. So this was great. In GemFire, we have a remote function. So when I talked about remote function, the function code is going to be running in here, where the data is. And so I have what's in GemFire terminology is called a region, called hashtag, and that's where the data. I'm going to create a tap from Twitter search. I'm going to create a tap to GemFire using XD. I'm going to feed that tap into the server, but to get the data out, I'm not using XD. I'm just using this REST endpoint. So the remote function implementation runs here. There's an interface that runs in the controller that's going to invoke that remote function. And so we'll take a look at that. So let me set it up. Yeah. Are we still in by? So I'm going to kill this guy to clear everything out. I'm going to start a GemFire server. So we provide a development edition of GemFire. We distribute it with XD. And the way you run it, it's configured with Spring GemFire. So this config Twitter demo.xml is setting up the region that I want to use. So we have a hashtag region, and we're going to create a client in XD that's going to talk to this server instance. So let me just start that up. Restart single node. And I want to also how about if we start my boot app? So this would run the boot app. You remember it's an executable jar, but I need to pass a parameter here. So I'm setting the HTTP port to 8081. Anybody know why I'm doing that? Any guesses? Because the other server is already using 8080, right? So, good. So I've got a boot app. The boot app is running, the REST server. Now I got to create some streams. So I'm going to cheat a little bit here. Yeah.
Which configuration told XD to use data-gem-ms?
We'll see that. Yeah. There'll be a GemFire sync in the tap. Yeah. So yeah. Yeah. When is this? Why isn't that coming up? Okay. Let's see. I'm just going to find a file here. This, believe me, is taking less time than it will for me to type it. Yeah, so I'm going to do this first, create a Twitter search. So create a stream that executes a Twitter search with a query. So I'm looking for a bunch of hashtags. I could do this on the Twitter stream. I could have used the same one that Luke used, but for the demo, I mean, I want to have stuff that has hashtags in it, so I can do some hashtag analysis. And then I'm going to set up a GemFire tap. So let's do this first. And now I'm going to create a tap to GemFire. So here's, hopefully this will answer your question. We have a sync module called GemFire server. I'm giving it a region name hashtag, so that's saying I want you to dump data into the region. So GemFire is basically a key value store. So you have a key and a value. The value is going to be a representation of the tweet, And the key is going to be the ID of that tweet. So I'm using a key expression parameter, which is a spell expression that's going to say, okay, extract the ID field out of the payload, the message payload, and use that as the key. Also notice that I have a transformer. So I'm using this transform processor, which is a generic Spring integration transformer that can either accept a Groovy script or a spell expression. In this case, I use a Groovy script. And what I'm doing is actually taking the tweet object, and I want to cache all of it. I'm just taking selected fields. So I have sort of a stripped down summary, which has the text, the language, the create date, and the hashtags. And so that Groovy script is doing that. And I'm just going to call it with the XD transform there. Okay, so that's running, and we should be seeing data coming into GemFire. Which, did we deploy it? I don't think I'm seeing any data going in there. That's the, let's see. Yeah, so we're getting some tweets. Oh, there we go. We're getting some entries here. It says created entries. So we should be able to go back to our browser now. To 8089 and call this associated hashtags thing, which we're not getting anything. What, no, this one is, no, this one is yeah, it's your HTML, right? 8081 is the REST service. Yeah, so we just don't have much yet. So something like the Twitter search is going very slow, unfortunately. So that associated hashtags was calling a remote function. Now let me just talk about that one. Maybe this thing will build up a little bit. So what I want to do is say I'm doing a search for certain hashtags, and I have like things like Java. So if somebody's putting a Java hashtag, they can also put other hashtags in the tweet. So I want to know what are the related hashtags for every tweet that is in that region that has a hashtag where Java exists. What are the other tags that also exist there? What's the total frequency? So it's a fairly complex type of analysis, best one I could think of for the demo, where you might have a large region of data and you're spinning through all the entries in that, and you're saying, okay, for each tweet in that region, I have an array of hashtags. I'm going to take out the target one I'm looking for in Java and can return the rest into a map and keep kind of a count of all those things, and then total the whole thing up and then sort it in descending order. So you see that the Spring comes out 2 times. So if I say so for the 2 tweets that had Spring in it, the frequency of other hashtags was this. So you get some interesting things here. But let me show what's behind the scenes, because I had to write some code for this part. So first, the boot application. So that's it. You run an application. Now you have enable auto configuration, which is a boot annotation that pulls in the Tomcat server in this case if it finds controllers and things like that. I had to also import an XML resource because I like to configure GemFire in XML. So I'm creating a cache client that can actually to invoke the remote function from a client. We'll see how that's done. So I've imported that, and I've done a little bit of MVC config because there's a bit where we did some asynchronous calls and we wanted to set up a timeout for long polling to 30 seconds. And then also we have a filter for cross-domain requests, since we're accepting requests from 9889 here. So that's the boot application. The controller, well, before we look at the controller, I want to look at the remote function. So here's a little bit of Spring data-gem-fire features. This hashtag analyzer function is the thing that does the actual logic for the aggregation of associated hashtags, and it's itself a bean, so it's annotated at component. And you notice this annotation at GemFire function, so that's telling GemFire when it's deployed into a Spring configured GemFire server, the Spring is going to, and you enable this annotation processing, it's going to look for methods that have, or classes that have methods that are annotated GemFire function, and it's going to register them with the GemFire function service automatically. There's also a bit here, a region data annotation. So this is a little bit similar to MVC controllers, like a path variable or a request parameter, where it's actually injecting that, mapping it to an argument. In the case of a remote function, the implementation in this case needs to operate on the region. So I can inject the region data into this method using the region data. In this case, I'm just using a map because the GemFire region is really a Java util hash map. So this makes it very easy to test this thing. I don't need to deploy this to test this code. I can set up some test data in a map and run it through and make sure this algorithm works. And then I need the target hashtag, and that's going to be actually a request parameter that the client is passing. So, I kind of already described what this thing does. It's just like it goes through each entry in the region. It pulls out the object. It's converting the target hashtag to lowercase to match, anything that matches that lowercase. It's going to compute the counts by basically removing that target from the list if it occurs in that, if it's a hit, and then looking at all the other ones. And then basically it does some sorting at the end. We also have another, I showed hashtag counts initially. And so I have another function in this class, and that's just going to simply count the hashtags and sort them also in order. So pretty simple. That is exactly the same as the field value counter, what Luke showed, the tag counter. But I put it here just to be, so I can just see what's in the cache easily, in one place. So that's the remote function implementation. Now, in the controller, I'm calling it, I'm executing this remote function, and this is an annotated interface. So it's similar to the way Spring Data repositories work. And then I declare an interface that's going to execute some remote function. So in this case, the method names map exactly to the implementation method names, but the signature is not the same. So there's no region data, there's no map. This is just the interface. I'm passing you this, and I'm getting something back. So it's annotated to run on the region hashtags. And all I have to do is declare the interface. Spring will create a dynamic proxy for that that will basically take care of all the GemFire, setting up the remote function call and using the underlying API. So that's it. There is one extra step. This actually returns a list of maps. Because like I said, we're in a partition region. We could be running on multiple members, and that list, when everything's done, will come back with the maps from each server. And so technically, I would have to aggregate those things on the client doing something, or use a custom result collector to do the grand totals of things. But in this case, since we only have one member, I'm basically going to just take the first item out of that list as the count. So if we look in the controller, I've got the region injected, which is in this case the client region. I have something called the hashtag analyzer executor, which wraps that interface, and it's going to call that, and it's going to get, and that's the thing that gets the first item out of the list and returns it. Not the best practice if you're doing it in production, but for the demo it was expedient. So I'm just going to call that thing, and it will invoke the remote function. So and map that to the request associated hashtags / whatever target. Also have hashtag counts the same way. So I don't think we'll have time to get to the continuous query part, but there was something called tweet watch where I give it a tag and I want to see all the, okay, well, we're getting a lot of S2GX tweets. Let me just monitor those tweets that are coming in. So I put out a continuous query for that tag, and I'm using the Spring MVC's asynchronous servlet support with the deferred result, if anybody's worked with that. So basically it's set up for a long polling kind of asynchronous delivery push back to the client. So whenever new tweets come in that contain that hashtag, it'll push it out to the client. I don't think we'll have time to demo that, but that was a little bit of code, because we're talking directly to GemFire here. This is not XD stuff. It's another app that's basically pulling data out of GemFire. So I think that's it. We could try to look at that page again, but what it was supposed to do with associated hashtags was give the bubble chart again, and basically having executed a remote function to get that data. So I think we're done. If there's any questions, let me bring the. Yeah. Get to the questions. It's my favorite slide. I stole from Mark Pollock. Yes.
How did you get the code that had the GemFire function? How did you get it to the GemFire server?
Well, that was the annotated interface when you saw it on region. Let me show that again.
You deploy a jar onto the GemFire?
Oh, yeah. Yeah, so we did, we skipped a step there. Yeah, so that function has to be deployed as a jar, so that hashtag, this hashtag analyzer jar gets deployed onto GemFire beforehand. So it was in the server class path already. Anything else?
If you're using clock as a source, it's like constantly pulling the file, checking tail, or how it's actually working?
What's that?
Can we use log as a source for streams? We don't have log.
Oh, no. Well, we have a tail source,
Tail source.
and we have a syslog source.
Okay, so tail is basically just really for any file you can constantly pull.
Yeah, I mean, with tail, it's using a Spring integration tail adapter. So basically, you point to a file, and you give it some parameters like how many records do you want to tail, if you want to do it, how many from the end do you want to do, how often do you want to check it, if the file doesn't exist, how often do you want to check for that file to be there.
Let's say we're using Log4j and we have a rolling, like every day new file creates.
Yeah. Yeah, tail doesn't work that well with rolling files, right? Yeah, because it stops when it rolls over. So yeah, that's a good question. So we don't have, we haven't thought about that use case, but it's like early days still. But yeah, we have a log4j source that would support rolling. If the tail stops and roll over, try to roll over. I don't know how hard that would be to do, but it sounds like kind of good use case for that. Any other questions? No? Okay, so the call to action slide. I encourage you, if you're interested in this topic and if you're interested in GemFire, to go to Lyndon Adams' talk tomorrow. There's also a kind of a cool demo that the sales engineers, the field engineers did in the demo lounge that is looking at XD to Hadoop and doing some real-time analytics with GemFire and fraud detection kind of thing. It's pretty cool. The more information on the project sites, you can go to Spring.io, SpringXD, or Spring data-gem-ms, to see more about the technology. The last slide here, if you want to see all the code for the demo, it's up on my repo.
So we get a 404 for Spring.io.video.
You have to talk to the event coordinator, or Chris Beams, if you know who he is. I don't know what's going on there. What's that? Oh, they got a 404 on Spring.io. /video. Spring.io/video 404. Try it. Yeah. No. I don't think we had that on our slide, right? It's an unrelated question, right?
Well, I mean, you had it on your slide.
We did?
Yeah.
Oh, Spring.io/video?
Yeah.
No, I didn't see that. Everyone has it on their slide. Yeah, but it's a nice 404. Okay, yeah, I don't know. I'm sorry, I didn't check that, but it was kind of a boilerplate slide for me. Yeah, it's the demo curse, right? It was /videos, was it? Oh. Well, let's try that. Yeah. Sorry. Anything else? All right, beer time. Thank you.